Hello students, welcome to class 12 physics. In this video we are going to solve the illustration of the textbook chapter number 7 alternating current. So let us start with 7.1. A light bulb is rated at 100 watt for a 220 volt supply. Find the resistance of the bulb. So here the power is given which is equals to 100 watt. Voltage is given that is 220 volt and we need to find the resistance. So we can use the formula P equals to V squared by R. I am taking R as the subject. R equals to V squared by P. Put the value of V and P in the formula. We get R equals to 220 square by 100. When we calculate this, we get the value as 484 ohm. So students, you may copy down this. Now part B of 7.1. Light bulb is rated at 100 watt for a 220 volt supply. Find the peak voltage of the source. So here the supply that is given, that is the VRMS value, and we need to find the peak voltage, that is Vm. And we know the equation that VRMS equals to Vm upon root 2. So from that we can take Vm as the subject. So Vm equals to root 2 VRMS. Now put the values of VRMS. So Vm equals to, here root 2 is 1.414. VRMS value is 220 volt. So when you multiply this value, we get 311.08 volt. So the peak voltage is equals to 311.08 volt. So students, you may copy down this. Now C part of 7.1. Light bulb is rated at 100 watt for 220 volt supply. Find the RMS current through the bulb. Now we need to find over here IRMS. So we have the value of power, that is 100 watt. We have VRMS value, that is 220 volt. And here, because the circuit is purely resistive, phi equals to 0 degree. So we can use this formula P equals to VRMS IRMS cos phi. Here phi is equals to 0 degree, so cos 0 degree becomes 1. So P equals to VRMS into IRMS. Taking IRMS as subject, we get IRMS equals to P upon VRMS. So 100 upon 220 equals to 0.4545 ampere. So students, you may note down this numerical. Now numerical number 2. A pure inductor of 25 millihenry is connected to a source of 220 volt. Find the inductive reactance and RMS current in the circuit if the frequency of the source is 50 Hz. So here the given data is L equals to 25 millihenry. So convert it into Henry, that is 10 raised to 3 Henry. Here source voltage is given, which is nothing but the VRMS value, which is 220 volt. Inductive reactance we need to find, that is XL, and RMS current we need to find, that is IRMS. In the circuit of the frequency of the source is 50 Hz, that means F equals to 50 Hz. That is also given. First of all, here because the circuit is purely inductive, we need to find XL, and we know XL equals to omega L. Here we are not given the value of omega, but we are given the value of frequency. So convert that into 2 pi f. So taking omega is equals to 2 pi f into L. Now put the values, 2 into 3.14 into frequency, that is 50 Hz, inductance, that is 25 into 10 raised to minus 3 Henry. When we calculate this, we get the value 7.85 ohm. Now we need to find the RMS current. So by Ohm's law, we know that I equals to V by R. Because here the circuit is purely inductive, we can take the inductive reactance instead of the resistance. So IRMS equals to VRMS upon XL. Here VRMS is 220 and XL is 7.85. So when we calculate this, we get to 8.025 ampere. So students, you may note down this numerical. Now numerical number 4. A 15 microfarad capacitor is connected to a 220 volt 50 Hz source. So here we are given the value of capacitance, that is 15 microfarad, which is 15 into 10 raised to minus 6 farad. Here source voltage is 220 volt, we can write it as VRMS equals to 220 volt and frequency given is 50 Hz. Find the capacitive reactance and the current RMS and peak in the circuit. That means we have to find capacitive reactance XC. We have to find both the current IRMS as well as IM. If the frequency is double, what happens to the capacitive reactance and the current? Then it is conditional, but first let us find the capacitive reactance and the RMS and the peak current. So capacitive reactance Xc is equals to 1 upon omega C. Here we are given the value of frequency, not omega directly. So we need to convert it. Omega equals to 2 pi f. So we can write 1 upon 2 pi f C. Now put the values of frequency and capacitance. Here 1 upon 2 into 3.14. Frequency is 50 Hz. Capacitance is 50 into 10 raised to minus 60 farad. When we calculate this, we get the value as 212.3 ohm. So here the capacitive reactance is 212.3 ohm. Now we need to find the RMS current. By Ohm's law, we know that I equals to V by R. But here we are using the capacitor in the circuit. So instead of the resistance, we take the capacitive reactance. So we can use the formula as IRMS equals to VRMS upon XC. Here VRMS value, that is 220 volt upon capacitive reactance, that is 212.3. When we calculate this, we get the value as 1.0363 ampere. So now we got the RMS current. From this we can find the peak current, and we know that IRMS equals to Im by root 2. So from this, taking Im as the subject, we get Im equals to root 2 IRMS. Put the value of IRMS, we get 1.414 into 1.0363. When we calculate this, we get the value 1.465 ampere. Now we need to check if the frequency is double, then what happens to the capacitive reactance. That means if the frequency is double, what will be the effect in the capacitive reactance as well as the current. Now see, the formula for the capacitive reactance is 1 upon 2 pi fc. So capacitive reactance is inversely proportional to that of the frequency. So if we double the frequency, that is instead of f, if we write twice f, then the capacitive reactance would be half. And so the current would be double, because here the current is inversely proportional to the capacitive reactance. So if this value becomes half, that is, we can say VRMS divided by the new capacitive reactance. Let us consider it as Xc by 2. So it becomes twice Vrms upon Xc. So here current gets doubled. So when we double the frequency, the capacitive reactance becomes half and the current would become double. So students, you may note down this numerical.